Hello friends! Over the past few years, I've milled cubic meters of wind-thrown logs into boards with a chainsaw, not just out of sporting interest, but for fun and practical purposes. From this recycled lumber, I've built a log cabin, a water wheel, a 12-meter arched bridge over a stream, and even crafted a boat and a sailing catamaran. Wind-thrown wood that has been lying on the ground for several years is often disregarded due to decay. However, by separating the decayed sapwood from the oily hardwood with a chainsaw, you can produce boards that will last for many years, even when used outdoors. My bridge and sailing catamaran are clear examples. The bridge has already survived 3 winters without showing any signs of decay and continues to bring me joy. Using a chainsaw and a homemade guide bar, I've created a pedal-powered lathe, workbenches, a shave horse, a forest tool cabinet, tables, chairs, and various household items. I've also built devices like a water mill, a forest washing machine, and a sharpening machine based on a water wheel. It's hard to believe, but I've made all of these and more in the woods, far from roads and sawmills, using only a chainsaw, 2 hands, and ingenuity. Some of these projects you may have already seen, and today you will learn about the homemade tools that made them possible. I hope within these few minutes I've effectively demonstrated the practical value of sawing logs into boards with a chainsaw right in the forest. Even when I have access to modern conveniences, I still mill logs into boards with a chainsaw, dry the material, and use it in my carpentry projects. For example, my friend bought a farm with felled oaks, and from one of the oaks I made a stand for my jet metal lathe, among other things. The oak slabs had to be dried, sewn into boards, planed, jointed, glued together, and then planed and jointed again. Grooves were cut, and only then were the workpieces joined with tenons. I also had to procure and prepare a piece of granite before mounting the massive granite top on the stand. The lathe itself needs to be securely attached to the granite top using a combination of spherical washers. With such a granite oak stand, the lathe becomes more stable, absorbs vibrations better, and operates more precisely. But I won't show the final result in this video. Let's keep some intrigue. A tree fell right under the road, and I had to dispose of it. From what seemed like rotten wood, I sawed bars for the frame of my workbench. The sapwood went for firewood, which I will burn in my stove in winter, but the oily hardwood yielded excellent framing bars. Of course, they weren't immediately ready for carpentry straight from the saw, but at my summer house I have a combined joiner planer machine. Compared to working off-grid in the woods, this machine speeds up my work tremendously and provides excellent geometry for the blanks. I must note that buying ready-made lumber from a sawmill is cheaper and easier. Therefore, self-preparing lumber isn't economically viable if materials and roads are accessible. But not everything in my life is dictated by economic feasibility. I view my carpentry and joinery work as entertainment and pleasure, and I can tell you with unwavering confidence that the satisfaction I get from items I've made entirely from logs is far greater than from those made with purchased plywood and timber. Stands for tabletop machines should ideally be made from solid, heavy materials to better dampen vibrations, and northern pine timber is suitable for this purpose. If all parts are jointed and glued with dowels instead of nailed together, the construction will be quite sturdy. I won't hide the fact that I take pleasure in knowing that the stand is made almost entirely from scraps, even though it might not look like it. Admittedly, pine is not particularly attractive. However, ordinary willow can produce boards with an expressive texture suitable for workbench or stand drawer panels. Drying willow wood can be tricky due to its tendency to crack, but I have some innovative drying techniques to share, which I will discuss briefly in a few minutes. For now, let's return to selecting wood for carpentry blanks. In the north, where we are currently located, oak, ash, and even maple do not grow naturally, and fruit trees are rarely sawn. Pine is soft and easily dented. Among the relatively hard woods available to me, birch is the best option. Many people dislike birch because its wood is white and dull. However, under certain secret conditions, birch can develop hardwood rich in natural tannin, which resembles walnut. Birch is also valued for spotting, fungal or bacterial colonies that create unusual colored spots or streaks. Regulars on my Patreon know that I've been struggling to finish assembling my DIY bandsaw for years. I lack time, I only have 2 hands. My summer house isn't in the taiga, and milling logs into boards with a chainsaw would be impractical due to excessive material loss from sawdust. However, sawing large beams from logs with a chainsaw is fine, since curve width isn't critical in this case. I'm determined to finish my bandsaw and start milling birch logs into boards with it. In the meantime, I use circular saw with thin curved blades for this purpose. You haven't seen my entire circular saw setup yet. It's worth your attention. I'd like to thank my subscriber Aslan from Paris for the idea of using a plunge saw with a guide rail as a primitive micro panel saw. I've noticed and appreciated the clamp lift idea and recommend it to everyone. However, since I mill wood at my summer house only occasionally, I find setting up the micro panel saw to be too much hassle. I use my DIY miter saw system instead. There is a separate video about it available here. Friends, join me in admiring the unique beauty of ordinary birch wood. My upcoming carpentry projects will feature birch, and I believe self-harvesting this wood is worth the effort, especially when purchased from my forestry at firewood prices. However, this wood is raw and requires proper drying. I've experimented with drying wood in sawdust, in the basement, in the attic, on the stove, and even with the magnetron. The most intriguing method I've found is using a large PET kegs. Daily temperature fluctuations inside the keg yield fascinating results. Since the sun and kegs are free, this method costs nothing, but it's a big topic that probably deserves its own video. As you can see, moisture evaporates from the birch bar, condenses inside the keg, and drains out through the neck. To prevent overdrying and cracking, I block convection with a sponge. You probably haven't seen this technique before. I should add that kegs can be assembled into long tubes for drying lumber, but I think drying boards longer than 2 meters, 6 feet, might be inconvenient. I forgot to mention that I also made a drill press stand using lumber milled with a chainsaw. I hope that in these first 8 minutes I have addressed the most popular comment on this video. Why mill logs into boards with a chainsaw when you can buy ready-made boards? It's cheaper and easier, right? Well, there are many reasons. The first obvious answer, try buying a board that spans the entire length of your bridge. Mine is 11.5 meters, 38 feet long, and made entirely from oily hardwood. Sawmills standardize their cuts to 6 and 3 meter, 20 and 10 feet logs, so this board is twice as long as what's available on the market. Transporting such lumber on public roads is also neither easy nor cheap. Suppose you need a hardwood board. How would you distinguish hardwood from sapwood in a ready-made board? Even if you settle for 6 meter, 20 feet sapwood boards, how will you deliver them to a roadless location? Sometimes it's more practical to use local materials rather than transporting them by helicopter. Many people abandon their goals when they don't see a clear path to achieving them, but that's not us. We will find a non-obvious path and push the limits of what's possible. Many of my subscribers have already benefited from the technique of sawing logs into boards using small chainsaws at their homesteads. In the end, it's a great pleasure to make something with your own hands from start to finish. Once you try, you'll notice that working with semi-finished products isn't as satisfying. Over the past 10 years, I've explored every known and unknown method of cutting logs into boards with a chainsaw. Today, I will reveal 2 more secrets that, as far as I know, have never been published before, or at least I couldn't find them online, despite diligent searching. I'll also respond to the complaints of detractors and share tricks on how to make a useful chainsaw guide bar that isn't available for sale or costs as much as a good chainsaw. Additionally, I'll discuss a custom milling guide bar that my friend Dan made for me at my request. Along the way, I'll warn you about the mistakes I've made and share some life hacks for metalworking and carpentry. A brief excursion into history. 9 years ago, I published a video titled Sawmill Made from a Chainsaw, 2 Boards and Screws. It showcased a simple device for cutting logs into boards, similar in principle to contraptions like the Logo saw jig or Alaskan mill. Although this milling method is not very productive, it is quite useful as it allows someone with no chainsaw skills to make a straight cut, and it's practically free. A setup made of 2 boards is much cheaper than a logo saw device and enables you to make a horizontal cut in a log that cannot be moved, such as this one that is a part of the log cabin. Later, I also made a logo saw-like device for my chainsaw, but I was disappointed with its low productivity, as I discussed 5 years ago in the video 2 chainsaw secrets turning a tree into perfect boards. This relatively popular video has gathered more than 20 million views across my 2 YouTube channels, and it's clear why. In this video, I first introduced the method of cutting logs into boards with sweeping motions, demonstrated the physical principle, and highlighted significant nuances. According to this method, you should move the bar through the cut faster than it can sink into the wood. Thus, you only cut with the nose of the bar without changing your grip. For more details, I will leave the link to it below. The method became popular, but many people only applied parts of the technique and didn't achieve perfect results. This incomplete milling cannot be recognized as the sweeping motion method. It's crucial to follow every part of my method. Some even accused me of plagiarism. I have no doubt this method was used by hundreds before me, but they kept it secret. In the video, I mentioned that I couldn't find any publication or demonstration of the method in the internet before my video's release. And in response, many began to send me links to videos where people cut logs into boards with chainsaws. However, these videos did not feature the sweeping motions. Typically, these videos showed people in the jungle cutting mahogany logs with powerful saws and huge bars. Yes, they cut beautifully and professionally, but used a completely different method. My sweeping motion method is only practical with small saws equipped with small bars. Firstly, because your arms would simply fall off otherwise, and secondly, a large bar due to its length solved the issue of straight cutting on its own. Just like a long jaw in a plane cannot dig holes in the board, a long bar cannot cut crookedly. My sweeping motion method is only applicable for low-power chainsaws with short bars. A long and wide guide bar positions itself in the cut and makes a straight cut without turning. No sweeping motions are needed. Note how the saw does flies like noodles. I can't imagine how one could confuse this cutting method with the sweeping motions milling technique. A large bar is very productive. However, a short bar has its own advantages. It is versatile, light, compact, accessible and cheap. You can't drag a large saw with a big bar through rough terrain and snow drifts. Obviously, this is a specialized tool for cutting lengthwise. A compromise can be found. Here's an example of how a large but lightweight homemade bar can be versatile. It is less stable in the vertical plane and not as productive. However, it is still rational to use it in the design of my self-propelled chainsaw sawmill. My experience has shown that it's better to cut boards with a self-propelled saw in several passes, achieving the cleanest cut while saving time, gasoline and oil. In this case, the saw always cuts only with the nose of the bar, resulting in only one saw tooth engaging with the wood at a time, removing a long chip without much strain on the saw. The bar length is not important, only the width of the cutting groove matters. However, there are nuances. I won't go into details as I don't want to repeat myself. I'm sure you're already familiar with them if you watched my video, Self-Propelled Chainsaw, Turning Logs into Perfect Boards. Unfortunately, there are no long, narrow curved guide bars with a groove width of 1.1 mm available for sale, meaning you can cut a log with a diameter of more than 40 cm economically with the self-propelled milling method or sweeping motions using standard bars. No problem, we have hands, heads and tools and can make what we need ourselves. Friends, here are my chainsaws and my arsenal of guide bars for them. None of these bars repeat. Among them, 4 are homemade and the rest are purchased. As you might guess, over the last 10 years I've accumulated a lot of experience using, designing and making them. Now I will share it with you. I don't have the technical capability or suitable material to make a bar from scratch, so I decided to take several budget guide bars and assemble one larger one. As practice has shown, this is the simplest and cheapest solution. I picked narrow curved bars with a suitable tail and a groove width of 1.1 mm. For an irrationally large amount of money, you can buy a long bar with a 1.3 mm groove. And of course, I took into account the chain pitch of my saw, which is 3/8 of an inch. Using a caliper and the trial and error method, I found the widest part of my donor bar, marked the cut line and cut the first bar in half. The crosscut shows that the bar consists of 3 sheets of metal riveted together. It would be great if I could just disassemble the bar, but drilling out the rivets proved to be too difficult. Next, I tackled the second bar. I obviously cut off the excess tail and nose of the bar, intending to insert the middle section into the split bar, but it's not that simple. To prevent the chain from sagging, the bar has a radius, meaning it is wider in the middle. To fit 3 parts together, I decided to widen the too narrow middle section. I marked a diagonal on the piece, ensuring it intersected all 3 plates in the package, and cut this piece in 2 wedges. By stacking the wedges together and shifting one relative to the other, their overall height increases. When it equals the width of the first bar piece, the task is solved. Unfortunately, according to Lomonosov-Lavoisier law, increasing the width shortens the length of the blank. This means that the total length of the bar will also shorten. These extras will have to be removed. In the meantime, I can check the future guide bar's dimensions. I will have to weld all the parts together using electric arc welding, meaning it's time to bevel the edges. You noticed that I still don't have a workbench with drawers. I'm using an old workbench. That's right, I haven't made the guide bar yet to cut the wood for that workbench. Determinism in action, yet we can freely move through time in the movie. The tack welds will hold the parts together for now, while I clean off the paint that will burn off during welding anyway. The rivets are now clearly visible, the steel around them is hardened, and even an R6M5 alloy drill bit can't handle them. Welding these bars pieces requires keeping the blank's geometry perfect, as a bent guide bar won't make a straight cut. I'm an amateur welder, so I took the simple route. I didn't dare to lay a continuous bead, which would warp the thin metal sheet in my hands. Instead, I added weld points on both sides in a staggered pattern. The result was acceptable. It's time to cut off the extras and chamfer the edges. Now comes another technical trick. We need to weld 2 sheets of millimeter-thick steel edge to edge without burning through or letting any metal seep into the groove, otherwise the chain will get stuck in the groove. Inserting a millimeter-thick piece wrapped in aluminum will do the trick. To prevent burning through the thin metal, it's better to reduce the current to a minimum. With an auto-darkening welding mask and a semi-automatic welder, welding is a breeze, but as they say, the best is the enemy of the good. On the last joint, I didn't mess up, but gained experience. I had to patch the burn-through spot. Of course, all the excess needs to be ground off, the seams need to be cleaned up, and the guide bar will be ready for use. However, as it turned out, a long narrow curve bar requires a long narrow curve chain. None are available for purchase. You can assemble one from 2 chains. I've assembled and disassembled chains with the 1.3mm tooth many times. You can find repair kits for these chains in any store, but I couldn't find a repair kit for chains with a 1.1mm tooth anywhere, so I made a jig to derive the chain. Fully pressing out the pins didn't work well. Using the pins from the 1.3mm repair kit also failed. I had to assemble one link from 2 broken ones, a method I strongly advise against. Seek a repair kit for a chain with a 1.1mm groove. I found that pushing or knocking out the rivets doesn't work. They need to be pulled out. To do this, insert a metal wedge between the plates of the non-cutting link after first grinding off the rivet heads. Then assemble one usable link from the ports of 2 broken ones and weld the chain together. Be careful not to weld one link to another. All links must remain movable. Branded and it's ready for testing. I etched my logo into the guide bar using a ferric chloride solution. As you see, a long narrow curved bar is good not only for sewing logs into boards, but also for precise joinery. The groove in my foot-powered lathe turned out to be quite precise. If you master the swinging motion milling technique, such a long bar is not needed for sewing boards. but a bar with 1.1mm groove is highly desirable in some cases. Look, I'm cutting a beam into boards along the market line, and the guide bar is touching the line, even though the cut initially started a finger width away from it. Can you guess why? There was a hint in the frame. Many remain silent about this, but it's important. You can share your guesses in the comments, and I'll reveal the answer in a couple of minutes. An extra long narrow curved bar is very handy for cutting short boards from a log as long as the bar itself. If I had this bar when I made the blades for my water wheel, the wheel would have been 1.5 times larger. After 2 years, the bar looked like this. The nose of it suffered the most. By the following year, the bar was completely worn out. I don't publish videos until I've tested a new method or tool for at least a year, or until it breaks. Only practice reliably finds the weak link. In this case, it took 3 years for the homemade bar to fail, due to the bearing of the driven sprocket breaking. This isn't fixable in the field, as the sprocket was initially too small in diameter. Let's jump a year ahead to the workshop and see how I fixed this guide bar. I found a short bar with a nose equipped with the largest sprocket wheel for a 3/8 chain with a 1.3mm pitch. Here's what the burnt bearing in a well-used guide bar looks like. A new sprocket will last noticeably longer on this bar, so the nose of one bar needs to be transferred to the other. Why am I cutting the bar lengthwise? For the same reason I cut the smaller guide bar into wedges and shifted them 3 years ago, increasing its width. I need to make the bar wider near the nose. Practice showed that the long longitudinal cut can be wedged without disrupting the tailpiece geometry. I was reluctant to use a whole bar as a donor, so I rummaged through the scrap and found the bar's nose from a previous project, though it was too short. Comparing the sizes of the two homemade bars, the fitting showed the old one wouldn't fit with the new nose, so I had to shorten the bar. Riveting a new chain is harder. Over 3 years, I never found a repair kit for this chain size. All that's left is to weld the new nose to the old bar and slightly reinforce it with a wedge insert. I plan to lengthen this guide bar and give it a rhomboid shape, so I didn't even grind the seams. It will serve as is. The best is the enemy of the good. An electric chainsaw has its advantages. It's quiet and can be used indoors. Here's a small trick. The width of the cut, and therefore the saw's productivity, is also affected by the bar's groove width. A 1.3mm tooth wobbles in a 1.6mm groove. The cut will be wider and the saw will jump at the cut, resulting in rougher lumber surface. It's desirable for the chain's tooth to move freely in the groove, but with minimal play. You can adjust the gap yourself, though it's a halfway measure. Unfortunately, I had to go this route. It's time to move on to larger forms. To make a straight longitudinal cut without swinging motions, the guide bar should be at least 90 cm, 3 feet. To prevent the saw from veering off in the cut vertically, the guide bar should be wide. With such requirements, widening the bar by shifting wedges becomes impractical. In a guide bar, only the tailpiece, a sprocket wheel, and a cutting groove along which the chain moves are important. The task is clear. Assemble one guide bar from 3. Practice showed that clamping the rail in the vise at the groove area can correct an excessively large gap. Considering wear, this procedure should be repeated after a couple of months. Try it. Your chainsaw will cut cleaner. Welding the parts follows the same process, but now in a trapezoidal shape. These complexities are necessary to maximize the bar's width. If all parts are assembled this way, the guide bar will be 1.1 meters, 3.6 feet long, which is what I wanted. Unfortunately, it doesn't work perfectly. The saw chain must have no kinks where it can sag, so the nose and tailpiece had to be shortened. All that's left is to weld the tailpiece and nose to the central part. The result is a Frankenstein guide bar. This is what the repair kit looks like. Its pins can be riveted without any welding required, which is very convenient. By the way, the rollout cabinets under the workbench have been incredibly handy. I've been happy with them for 4 years. Another important nuance, my experience showed that for the bar to cut perfectly, the links in the chain must be strictly perpendicular to the guide bar's plane. You can check this by placing the bar on edge and applying a square. It should form a right angle. Then the bar will not veer in the cut, provided that the right and left teeth in the chain are equally high after sharpening. I recommend using an electric abrasive sharpener. Once everything is set, you can head to the forest for mushrooms. I think you noticed about 15 projects in this video that haven't been published yet. The queue is long, and choosing which video to edit and publish first is not easy. I'm counting on your help in this matter. Please let me know below which project you would like to see on my channel first. Thank you in advance. So we had a short break. Let's get back to the remaining secrets of the chainsaw. I made this cut 4 years ago, and in it grew the tiny pine and mushrooms. They're so delicate. This pine died about 20 years ago, but its hardwood is still suitable for building my bridge. If you make a cut at both ends of a 2 meter 6 feet log with a 1 meter 3 feet bar, you will get 2 meter boards, but usually boards need to be shorter. In this case, I needed boards 1.2 meters 4 feet long, and the surface quality of the cut didn't bother me much since I have a scrub plane. The right tool makes all the difference. With such a nice, compact and inexpensive guide bar, I made these huge clamps for bridge construction in just 20 minutes. Sure, there are larger bars available for purchase, but they cost more than a chainsaw and they're narrow. I think it's time to reveal the answer. Look at this board. Notice the diagonal cuts on it, but only on one side. It might seem like I can't make a straight cut, but it's actually the opposite. I needed to make a curved cut, which is almost impossible with a long bar, and I didn't have a short bar on that trip. Here is the key point. If you cut a slab from a log, the log will bend. When milling a log over 10 meters, 33 feet long, the height of the resulting arch along the marking line can reach 5 centimeters, 2 inches. To keep the board a consistent width, the next cut has to be curved. Essentially, when you make a perfectly straight first cut, removing the outside slab causes the log to bend in an arc. The bend is unnoticeable when milling shorter boards, but even at 6 meters, 20 feet, it can be about an inch. Note, I don't know how to freshly cut wood of this length behaves in this scenario, as I lack experience with it. Friends, don't repeat my mistake. If you're cutting long logs into boards with a long bar, make all the cuts at once, leaving thin bridges at the bottom of the cut so that on the last pass, the log splits into 2 full slabs and 2 side boards. Alternatively, you can use a short bar with swing motions. It's way easier to make a curved cut with a short bar. My years of experience with swing motions log milling blinded me, and I only realized that it could have been done easier and better after finishing the work. I wish someone had told me earlier. And here's another warning. A few years ago, I got carried away, rushing to build a bridge in one vacation, milling boards with a heavy saw trying to make curved cuts. I worked 10 hours a day for 10 days straight and injured myself, ending up with epicondylitis in both arms. I'm a former professional bowler with well-trained forearm tendons, yet they couldn't handle it. Please take care of your health and don't rush yourself too hard. Another piece of advice. Take time to prepare. Work in comfortable conditions. As you can see, if it's raining, I wear waders and a jacket. When the rain stops, I take off the jacket, and when the sun shines, I dress accordingly. I always try to position the log so that it is convenient to cut. I don't have a second back. It's better to lose a day for prepping, but then finish a task safely in 5 minutes. And never ever work with a dull tool. I don't recommend sharpening the saw chain by hand. It's better to use an abrasive grinder. It's inexpensive and provides very high repeatability of the cutting tooth height. But if you have no other choice in the field, you can touch up the sharpening by hand. Finally, if you're cutting along the grain, there is no point in sharpening angle of less than 30 degrees. I checked specifically. However, the topic of sharpening tools is too vast, and I will dedicate a separate video to it. Stay tuned for updates. Now, let's move on to the highlight of the program, my biggest DIY guide bar. My old friend Dan made this bar for me. I currently don't have such technical capabilities, but he has access to an experimental factory shop. I'll say right away, the bar pleased me. Look at how the wooden shavings fly. It's a pleasure to watch. Surely many of you, while watching the video, wondered, why make a bar from scratch? It's so inconvenient. If it were possible, I would have assembled such a large bar from pieces just like my other Frankenstein bars. Unfortunately, such a big sprocket is not available for purchase. Even Dan, with his extensive metalworking experience, faced a heap of technical difficulties. For instance, he couldn't harden the bar, the sprocket, and to rivet the bar. He had to build a special stand. Many blanks were destroyed during the experiments. Watch how the bar sinks into the cut. Cutting with it is a lot of fun. We tried our best, but the guide bar still didn't last long. The bearing burned out. It's a big problem. Such tempering colors bode nothing good. Essentially, it's a fatal flaw, but there are other problems with the bar. It's not entirely straight. As you can see, there is a slight wave, and the nose of the bar noticeably drifts to the right. In principle, the curve here is minimal. Such a bar can be used to cut back along the line, or if it's already in a deep cut, but not forward. Dan did the right thing by riveting the bar from the inside out in staggered steps, like a cylinder head, but it should have been riveted like a clutch disc with flipping. Live and learn. I evaluated the technical tragedy and decided to finish the tests by running this bar to the ground, as well as to see what happens if the bearing is cooled. Of course, the load on the chain is high, and the new chain stretched immediately. I had to stop to cool the bar frequently. Each minute the bar cut worse and worse. The chain didn't dull at all, but turning the sprocket became hotter and hotter in the saw. Upon inspection, it turned out the problem wasn't with the bearing deteriorating, but the sprocket teeth. The caliper readings showed 2.43 and 1.55, indicating that the bar cheeks in the nose area had spread catastrophically due to burr deformation on the sprocket teeth. The bushing, which was painstakingly pressed into the sprocket on the third attempt, got stretched. The rolling elements gouged a groove in the bushing, causing one of the rollers to get stuck. Look at the deformation that the chain imprinted in the sprocket. This deformation hindered its rotation. Additionally, the rolling elements got flattened. Fortunately, my friend didn't give up and plans to continue the experiments. Advice and recommendations are welcome. First of all, I need to clean up after myself. I have big plans for these wooden chips, but I'll reveal them another time. I think I still have some surprises for you. We have unique forest lathe work with the chainsaw coming up, the solution to the mystery of the round window in the cabin, and a few other devices that I'm keeping as trade secrets for now. Anticipating your question, the material for the new video about bees has finally been filmed. It just needs to be edited. Friends, in this video I have compiled and summarized my extensive experience milling lumber with the chainsaw and shared with you what might be exclusive information in this field. This was Maxi Gorov, and let good people watch good videos. I hope to see you soon on Advoko Makes.